Section 2.2, we're going to be talking about measuring segments. So if we get a diagram like this with AB, the length of AB is the absolute value of the difference of their endpoints. And I'm saying absolute value here because we could never find a length of something and it would be negative. So if I had a diagram like this, I could measure AB going either way. I could count this going 1, 2, 3, 4. I also could count the other way and find that the length of AB is 1, 2, 3, 4 as well. So in example number 1, let's find the length of segment ST. Again, I could count either way here. So to count ST, I could start from S or T. It looks like each coordinate's going by 2, so this would be 2, 4, 6, 8. So ST would be 8 units long. If we wanted to find the length of TV, we'd do the same thing. 2, 4, 6. The length of TV would be 6 units long. Finally, if I wanted to find the length of SV, let's just start from V this time. 2, 4, 6, 8, 10, 12, 14. So SV would be 14 units long. Notice here how I didn't really pay attention to the negatives. When I'm finding length, I don't really care if I have a negative value. This leads us to the segment addition postulate. So this is where we're going to kind of work in algebra with this. If 3 points A, B, and C are collinear and B is between A and C, then AB plus BC would equal AC. So this might make a little bit more sense if we see a picture. So here we have AC, B lies within that line. AB and BC would add up to give you AC. So in the example problem, let's say the whole segment EG equals 59. I want to then find EF and FG. So notice here that our missing variable is x, so we have to use the segment addition postulate to make an equation. We know that by the segment addition postulate that EF plus FG should equal EG. We can see that EF equals 8x minus 14, so I'm going to replace it with that, plus FG, which is 4x plus 1, equals EG, which we've been told is equal to 59. So now we're really left with an Algebra 1 problem. So all we got to do here is combine like terms and solve for x. So I'll combine like terms. Now I'm left with 12x minus 13 equals 59. I'm going to get that x by itself. I'm going to add 13 to both sides. Finally, I'm going to divide by 12, and I'm left with x equals 6. Notice here that in this problem, I'm asking to not find x, but I'm asking to find those actual segments. So this last step, which is easy to forget, I'm going to plug x into both of those equations, or expressions. So to find EF, I'm going to plug x in for 8x minus 14, or 6 in for 8x minus 14. 8 times 6 minus 14 gives us 34. So EF is 34 units long. I'm going to do the same thing for FG. Plug in 6, I get that FG is 25 units long. Finally, to double check, I know that the whole segment equals 59. 34 plus 25 does equal 59. In our next example, I want to find the length of AD. So I'm given bits and pieces of this, but I want to figure out what the whole segment equals. I can't do 14 plus 12 because those are overlapping. So here's what I'm going to do. I need to find out what CD is. I know that BD equals 12 and BC equals 8. So the leftover segment, 12 minus 8, gives us 4. Do the same thing on the other side. I know that AC is equal to 14. That small segment BC is equal to 8. 14 minus 8 leaves us with 6. So finally, to find AD, I would do 6 plus 8 plus 4, which gives us 18 units.